Well, hi, good morning, and thank you so much for joining me in my shop here. Today is June 24th, another scaldingly hot day. Yesterday, my wife and I pretty much stayed indoors all day. We'll probably do the same thing today because it's just so hot and humid outside. Okay, and what about this thing in front of me here? Look at this machine. This is called a Logafier, as in amplifier, logarithmic amplifier. Logafier. What is a logarithmic amplifier? So someone gave me this and said I might have some fun with it, and I'm trying to have some fun with it. What exactly this is, I'm not 100% sure. I believe what it is, it's simply an RF amplifier that can operate all the way. It's got two range settings. The lower range setting all the way from 20 kilocycles up to 220 megacycles. And in the higher setting, it's 200 kilocycles all the way to 220. Why would you never have it set to the broader band? There's some switches inside that have to be switched to switch between these two settings. This is a transistor device with two vacuum tubes. It's a hybrid amplifier. The two vacuum tubes inside it I've tested, and they were very weak. I've replaced them with decent ones. I have tried operating this by connecting an antenna here where it says RF in, 50 ohms, and out of here, where this must be the output, it says RF out, 50 ohms, 0.3 volts max, which is kind of interesting. It has a switch here. One setting says internal, and the other appears to have this writing on it. I don't understand what's going on there. There's a 0, probably for the meter. There's a sensitivity adjustment, again probably for the meter, I'm not sure. The other controls are line gain, or linear gain, I believe is what this would be. Expand threshold. I really don't know what that is. I got a guess, but I don't know. Expand on, this must turn on this expand threshold function. This control appears to adjust the meter. I'm not sure of that. Full scale, someone has put these on, these labels on to help themselves, I guess. And they've converted this 40, 60, 80 into voltages. 0.5 volts, 0.15 volts, 0.05, and 0.5 millivolts. This is made by a company called K Electric in a place called Pine Brook in New Jersey. So that's pretty much the front panel. There's also an output here. It says vert on it for vertical, and I have to guess this must be going to an oscilloscope, to the vertical input on the oscilloscope, so you can see something. What's the purpose of this? A logarithmic amplifier amplifies weak things more than strong things. Now that sounds like an automatic volume control or an automatic level control that you find in lots of radios. What's so special about this? I think, and this is the part where I'm not sure at all, it's a broadband amplifier. So it's amplifying all the signals in a band, like all the way from 20 kilohertz to 220. Everything is getting amplified. But in there, the stronger signals don't get amplified nearly as much as the weaker signals. How it does that? Well, look at it. That's how it does it. It's a big machine. A big hybrid machine. And am I right about that? I don't even know for sure that that's what it would work. That's how it would work. This is what I've gathered from what little I've read on it in my messing around and thinking about it. The actual model number is 1025B. Okay, it's in my shop here because I can test it a little bit more thoroughly by applying controlled signals into here as opposed to just an antenna. Controlled signals in, and we can watch what's coming out, fiddle with all these controls and see what happens. My guess is this is not working, and many of the transistors inside it, which I think I'll have this out of its cabinet shortly, are socketed. So this is early enough that they were still socketing things, like they socket the tube. I guess it made sense to put a transistor in a socket. I would think those transistors in sockets are a little questionable contact-wise. So it could be as simple as one transistor, one lead is just not making contact. It could be anything that's going on in here. Even the power supply could be dead. These high quality machines from around this vintage, there's a good chance they still work. They're made with good components and made very rugged, and they're designed to work trouble free for their entire life. That's the hope. So these kinds of machines, you could find them working. Whereas you go back to an old tube radio, not much of a chance of just grabbing one and having it work. Okay, I'm going to set a little bit of equipment up here and we're going to poke around a bit more with it. This is the manual for the Logafier. It's in English. This is a French website, and here it is, and we can look at it. Now unfortunately it's just not quite clear enough to read easily. Bits and pieces you can read. This is some kind of test setup when you first get it. It says here, check something or other procedure. So this diagram is kind of what I'm going to try to imitate. If we look at it, here's the Logafier here. This is a detector, and then you've got it showing it. They've got it going to the scope here. Horizontally, they've got it coming through a sweep generator. And this device, let me click on it here. I think it says attenuator. Well, that doesn't quite make sense to me. That should be signal generator, shouldn't it, right there? You have a signal generator of some sort, and it's feeding down into the Logafier here. And they're detecting it, and then it's showing up on the scope. Why didn't they use the vertical here? So here's another setup. What are they doing here? It says, what's it say at the bottom here? Logarithmic range check. That's what it says. And here it says amplifier gain check. Well, let's go to the next page. There's the schematic. Oh, I think that's as much as they're going to let you see. That's it. I think that's it. So, I think it makes sense what I'm going to try. I think what I'll try is I'll take my signal. I have a signal generator that I can actually use a lower frequency one. I'll just use the machine on lower frequencies. Signal generator, feed it in here. I'll take a scope of the feed going in. I'll take the feed coming out. I'll scope that, so we'll see what's going in, what's coming out, and what more can we do? And then we just vary the signal output here and just watch what happens. If anything happens. I have my doubts. I'm going to be able to make this work. But I'm going to give it a good go. I should have said something right at the start about the project I've been working on. Just sitting over here. This old radio here. I'm just taking a break from this. I've sort of hit a difficult spot with the repair. I need a couple of days to think and come up with some kind of idea. So we're going to feed this guy with a signal from him, and I'm just going to stop the video while I get some cords hooked up and stuff like that. Okay, I think we're ready for our first test. So I've got a signal generator here. And we're going to set it to 4 megahertz, something like that. We'll see what it comes up at. The output from the signal generator is coming along, coming right into here. Then a feed comes from here, showing exactly what the input is here, going up to my scope. Up here, you'll be able to see a little better in a bit. Should turn it on. And then I also have the output going up to the other channel on the scope. It's a 2-channel scope. So we should be able to see input and output. Let's set the scope up properly here. So we're going to want to start with the 2 channels set the same. And what would that be? What did we set it? 0.1. Turn this on. 0.1 would be a good starting point. 0.1. You can see the two lines here. You can see the scope can only draw one line at a time. It can only draw a point. It's all it can really draw. It's just our eye that makes it look like a line. So we'll just move the top one up. That's the output. You know what? I'm going to put that one at the bottom. And we'll move the other one up a bit. There. And we have both these set to AC only. Might be interesting to see if there's any DC there. We can speed this up. So we have a line there. And a little more brightness might be good. Okay, so first I'm going to raise the input until we can see it on the scope. Which will be the upper line. So we're going to go up by a factor of 10. There, you can see something is there now. So let me check the calibrations over here. You can see it varying a little bit as I fool around with it. Let's go up a level higher. Now that's a huge signal. Well, we can actually measure it, can't we? So we're set to 0.1 volts per division. So 0.1, 0.2, so it's roughly the same as the maximum output of the device. So let's knock it down by a factor of 10. So we'll be feeding that into it. This is what's coming out. Nothing right now, of course. Hopefully what comes out is a bigger thing, depending upon the setting of the controls. So I'm going to just fiddle around with my camera settings here so we can see everything all at once. And you can probably hear my air conditioner roaring away in the background. Okay, so we're just about 5 megahertz. Let's do it at 5. That's an okay number. 5 megahertz. Okay. Now we want to keep an eye on the scope while I turn this guy on and see what happens. First of all, let's go down, down, off. We'll leave this, I don't know what this switch does, internal or that. Okay. We're plugged in. I don't know if I have my power bar switched on. I think it is. Here we go. Okay, now there are tubes inside. So look what's going on there on the scope. Some kind of, I don't know what would do that. It could be DC voltages coming and going. Since I have the scope set to AC. Okay, so looks like a little tiny bit is there. Ground the input briefly and just watch this to see if it gets thinner. I can't see anything. Oh, wrong one. That's why. Maybe a tiny bit thinner. Okay, let's crank up some of these controls down and see what happens. So this is the what I believe to be linear gain. Whoa! 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 Did that ever go? That meter just flew over too. Oh my gosh! Let me go slower here. Wow, okay. So now this is kind of messy in here, so something funny is happening. Put this up higher. Oops. I'm going to take away the wrong one. I'm going to take away the input. Let's look at the output. Move it up a little more central. Oops, wrong control again. I think this extends down further. Let me pull back on the. No, maybe not. So this is not smooth though. I mean, there's a line, and a line up there. Why would that be? I don't know, but wow. And the meter's just going up and down there. You can hear it whack in the end. Wow, this really does seem to be working. Sure does. Because the input signal is this little amount here, and the output is that, and I can crank it way up. Okay, that's interesting. That's really interesting. When I tried this with radios, I couldn't get any effect that I thought was indicating that it was operating. But this really makes it look like it's operating. what to try. Well, we can, this says 0.5 millivolts, so the meter's very sensitive on it. I got one higher. A lot of funny things going on with this meter. Good luck explaining that. Let's fool with the gain. Watch the meter. What's happening? The meter's not moving enough. Down to nothing. What happened on the scope here? Where'd it go? How could it disappear? Anybody want to take a guess? Where could it go? I have a thing called a finder here. If I can, this one right here. I don't know what that tells you. The scope's not triggering. I shouldn't have to trigger. Added triggering on the line. Both channels on. You know, I can see flashing in here. Well, one of these has got a huge. The whole screen is flashing. Is that the right one? That's not the right one. This is the output one. This one up here, dummy. I should. You know what? I gotta switch these. I'm just caught up in the idea that the one in the top is the input and the one in the bottom is the output. I better set them that way. Okay, now we got to reverse these positions here. So this is the top one. We'll put it up at the top. It's blazingly bright. And then we'll put the other one at the bottom. The other one we can't see. How come? We can't see. Where are you, man? Something funny going on there. Let me disconnect the signal entirely. No signal. We're seeing the upper one. Where did the lower one go? Oh, there it is. Okay, there's the lower one. I don't know what was going on. Off the screen, maybe. Okay, I'm going to connect the output back up. That's the lower one now. And it blew the upper one off the screen. How does that happen? How did that happen? I'm going to reduce the input signal. Increase the brightness here on the scope. I'm going to slow the sweep down. Funny things happening with the camera from the shuttering action. You're seeing angular things here. That's a camera effect. I'll just go up a speed. Go up a speed. Still flashing. What's happening, man? You got me. So you have the input on the top, and it looks like almost nothing. And we have the output on the bottom, which looks like a lot. And they're both set 0.1 on the scope. The input signal is a line, and the output, it looks like that. This is on the 40 setting. With the gain at nothing. Now if I turn the gain up, so it looks like this gain control only affects things when this is set to linear. That makes sense, eh? Linear gain. So maybe the name of the game is you flip this to linear. This is a linear amp at that point. But if you don't want that, if you want this compression thing going on, then you set one of these other 40, 60, or 80. Turn the expand on. Expand? I thought you're supposed to shrink it. Expand. I guess it's expand. It says expand. expand? I thought it was. I wouldn't call it expand, but I don't really know what's going on. So who cares what I think? Let's keep goofing around. So we'll go back to the linear setting. Okay, and we'll turn up the gain. How come this line went up? Let's turn the brightness down just a little bit. Burn through the glass on my scope. Input level is low. Let's raise the input level. Okay, so now we see a little bit up here. Still on the 0.1 volts. We don't see anything down here, and advance the gain. Here it comes. Now at this point my scope starts triggering. So I'm going to put this down on a line so it's always triggering. That looks ugly, doesn't it? I'm just going to put it there. And you can see you can't see what I'm doing. Okay, as I turn the gain control up and down, it makes a huge difference. So I'm feeding in a moderate signal over here. Let me reduce it. This is more typical of a sort of a strong signal from an antenna. Well, we can still expand it. You know, is there any logarithmic activity going on in here? I'm not even sure how to judge that. But it looks like, sure looks like this is a powerful RF amplifier. That's what it looks like with a control here. Okay, so we'll go over here, we'll turn this on, we'll fool around and see what happens. Kind of got an idea what's going on here now. So we'll go to 40. Now what happened? I think it got much bigger. Did it? So I'll turn up the brightness again. Yes, it did. Yes. So it's bigger now. But what about the linear gain control? Has no effect. And this will have no effect. I haven't turned this on yet. So now this is having an effect. So that's a 40. That's a nothing. And that's a whopper. So it looks like this is almost like a amplifying range. Okay, so we'll put back to linear. Turn this up a bit. We'll flip the switch on. Oh, some kind of interference showed up immediately or something. Look at that. What is that? Strange stuff. Almost like something was ringing in there. Okay, so we're still on linear. This time expander's on, so this is still doing what it did. What's this doing? Oh, maybe you can't see them in the camera, but little yeah, maybe I'm imagining it. Okay, so we'll go to 40. It's bigger. Now we'll turn up the gain. Use linear gain. There's nothing. I better not use the word again because it's going to make it. Here we go. We're turning up the threshold. Oh, wow! Did you see that? I got to a certain point. It just jumped off. Right there. It's just starting to jump up. You know, the control's called threshold. I would guess I've reached a threshold of some sort. And maybe what it is everything underneath gets amplified and everything up above doesn't. That's crazy. That's a crazy notion. I would think it's a logarithmic variation of gain over the range of frequencies involved. Does that even make sense? Sounded good. If you think about it, it doesn't make any sense what I just said. We'll go to 60. I get a straight line. No, not this time. Straight line before when this was. So this is doing something now. Okay, and we go to 80. Bigger yet. And it's so big I've got to change my scope setting here. There we are. That's now 1 volt per division. The output here is supposed to be 0.3 volts maximum. And at 1 volt per division. That's over 0.3, I would say. And the expander. So if my thinking is right, then this thing is a device which is able to amplify weak signals in the presence of strong signals. I gotta set that kind of scenario up somehow. I gotta give it a weak signal and a strong signal. How am I gonna do that? I think there's still more to fiddle around with here. Right now we're working with 5 megahertz. You know, I could put the output onto my SDR, and we could look at it there. That's a good idea. That's such a good idea. I'm going to stop for a minute and get some coffee happening here. Okay, that should give you lots of stuff to look at. So right now, the signal generator is still running at around 5 megahertz. You can see it. And on the SDR, you can see a very strong signal right here at 5 megahertz. They got to be the same. But to prove it, I'm just going to vary the signal generator a little bit. We'll see it. We go back and forth. Okay, that's good. Now, see, there's something off to the left there. That could be an artifact of the SDR. Could be coming out of my signal generator. I don't know. Could be coming out of this thing. Don't know what that is, but we're just going to ignore it for now. So we have a very strong signal coming out of this box. We're on the 80 setting, which means we're involved in this threshold setting. I'm going to back it down. We'll watch the SDR. Nothing happened on the SDR. Now what about the scope? Nothing happened on the scope. Okay. What about this guy? Nothing anywhere. So let's go back to where we started. Turn this down, turn this down, turn this off, put this here. So we're on a linear setting. I'm going to adjust the linear gain and see if that signal starts showing up. There it is. Ooh, where are all those other guys? Oh my gosh, look at all that stuff. What is all that stuff? They're hopping around as I just changed the gain a little bit. They're doing all kinds of weird stuff. So again, could be my SDR. There's a signal to noise ratio to consider here. And if you stick my mouse over here while watching this, I'm going to try to raise this until the noise level begins to climb also. So we'll go down, we'll go up, up, up. The noise level is going down. There, it starts coming up. What are all those other weird things? The meter went right over and then lots more showed up. It could be overloading this. I could be putting too high a signal into this. What am I feeding into it right now? I'm feeding in 10 times. I'm feeding in 1,000 microvolts. 1 millivolt is what's going into it. And 300 millivolts can come out of it. This is probably too high, so I'm gonna knock this back by a factor of 10. Okay, let's see if we can just. Oh, it didn't disappear off the screen. Off the SDR. Let me watch. Let me do that. I'm going to go up and down and watch the SDR. Oh yeah. Oh yeah, okay. Let's go down another one. Okay, that's a pretty weak signal now being fed over here. That would be that'd be 10 microvolts according, if this is all working properly. So it's in the range of 10 microvolts. Could be 30, could be 3. I don't know. But anyway, it's showing up now. If we fill with this. So that thing came up over at the right there, left rather. But then it goes away as you do this. Is that very strange? I don't know how to explain any of this. You go right up to the top. So that's my coffee maker saying, "Come get some coffee, Jim." Okay. Let's fool with these other controls a little bit. So I'm going to turn this down, flip this to 40, flip this on, flip this up. Oh, we did do a little bit of something there. The meter comes up just a wee bit. 60. Okay, and on the 80. This controller doesn't do anything. It's strange. It doesn't seem to be consistent operation. Off. This doesn't do anything. Nothing going on at all here. The 60. This could be why when I played with this, I didn't realize that some of these were behaving differently. I just figured, 60 is 20 more than 40. I didn't really think much more about it, but we can see that these things behave very differently, these different settings. Well, I think the next step is to start listening to some radio through this a little bit. I'm going to switch this input with an antenna, and we'll look on the SDR and just try to figure out what's going on based on a little bit I've learned from playing around with the signal generator. Okay, so we're going to disconnect from the signal generator here. I'm going to connect up to my outdoor antenna. Oh my gosh, I'm not sure it's switched on. Shortwave working a little better these days. Last night I noticed quite a few signals on the 49 meter band that weren't there. So this is an outdoor antenna now, and so we can watch what happens on the SDR as I connect this up. So a little bit way on the left side showed up. I have to go make sure the switch is on. So I'm just going to leave this running. You just take care of things while I'm gone for a few seconds. Okay, the antenna is switched on. So, oh, what happened there? Was that me? Did I didn't do anything. I did do something. You know what I did? I switched. So my antenna comes into the house and it can go in 3 directions. And one is down to the shop here. Another one is over to a desk with a bunch of radios, and the last one is to a desk with a bunch of computers. And so I'm flipping these switches, and you see me run out of my shop. I'm turning on the switch that feeds it down here. What I did just now is I turned off the switch that feeds to all the computer equipment, which is not running right now, and that caused all these lines to show up. So much is inexplicable. Okay, so what we want to do is we want to go down. So we're not going to pick up any shortwave stations here. Let's go down to the broadcast band and see what's happening down there. Okay, so here this blue line is the AM broadcast band we're all familiar with. 1010 is a station. Here we are. Excellent.
The number one swear word that everybody loves the most, as you won't be surprised to know, is the F-bomb. So that at least we have that in common. That unites us.
I think the president swore yesterday, and everyone's talking about swearing now.
I'm sure you're right.
Okay.
This is something we agree on, Mike. It's such a divided world. At least we can agree on that.
We're still on the still on the scope. Here. Now we're going to turn up the gain here. I'm on linear. We're going to turn up the gain. I'm going to watch what happens on the SDR and listen. Actually, I'm going to turn it down first. That's a better idea.
It measures your inhales, your exhales. It measures the difference in flow rate between the 2 different nostrils. It looks at, whether you, when you're sleeping, how you breathe. And from 24 hours of data, an artificial intelligence algorithm can figure out very accurately who you are, such that if they recorded your breathing down the road with one of these devices...
Now, is this supposedly any better than it would be otherwise? I don't think so. At least it's amplifying. Okay, we'll try some of the other settings.
We all breathe a little bit differently, that's fine. But it does sort of make the argument... And I'm not worried anybody's going to monitor no breathing.
40 and 80 seem to be the same thing.
And other algorithms can work for how I compare my walking gait to the walking gait of others. You know, when you think about making rules or having legislation from being identified as we walk through a mall and having our identity known to all the stores that are there so that they can prey on us.
Just turn down the volume here a little bit. What's going on here? When I push this expand threshold, it looks like the noise goes up, but the signals don't get any stronger. Is this the attempt to amplify the low signals? Or is it just putting up the noise? 80, 60. Oh, that's pretty interesting there. Look at that, I got a full range of something. Okay, so hear what it sounds like. I'm going to turn it up a little bit, then I'm going to switch the antenna to directly to the SDR without any other stuff going on. Can I do that easily? Can you do that easily? I can if I grab one of these. Okay, so this is the antenna coming in. So you're going to want to take this. Okay, look at the display. 1010 is minus 45 on the display, minus 70 is the noise. Now this one here, here, and here. This is now the outside antenna. Okay, so now the 1010 is at minus 55 and the noise is at minus 80. It's a little lower. So it looks like just everything kind of went down a bit, noise and all. I thought some of these SDRs will give you a signal to noise ratio value. Looks like this one I've got won't do it. Well, that's all pretty interesting. That's very interesting stuff here. Okay, so we're this is the antenna. Well, it seems to be almost a neutral effect here, not really helping out much at all, but interesting. Let's go up and try to find a shortwave signal. So this thing should be amplifying all the way up to 220 megahertz. So we should easily be able to go up to, let's say 15. We'll look for 15,770. Why don't we do that? See if it's there. So it's there. You can see the carrier, but it's not enough to listen to. So let's go back. I gotta do this again. We gotta go back to. You can hear it a bit, eh? Figure out how to do this. Take this, and we're gonna go straight on the antenna. I don't want to get it wrong. Straight on the antenna for comparison. So this is antenna to SDR. We're getting minus 60. Minus 60 there. And you can kind of listen to that, I would say. Turn it back on. Of course, the shortwave signals are fading in and out, they're fading quickly, they're fading slowly, so a little tricky to do this kind of test with a switch, switching it back and forth. So we can see from the waterfall display just off the bottom now, the noise level's gone way up with this. Let's see if we can get the signal to come through here. Try this threshold control. Maybe it's, it could be it's faded right out and it's gone. Okay, we'll flip this to linear. Oh, I can hear it now. Okay, we'll leave it there. You can see the signal here is going. So you can watch this number over here, 23. Sweet spot, just before the noise level starts coming up. Okay, now we'll flip this over to here and we'll try this. Just waiting for it to hear something. Can hear it here, cannot hear it on linear because this is too low. Just barely hear it. Noisier. Oh! I can hear, I'm not looking at the meter, but I can hear it whacking. These all seem to work just a little different. Fact is, I need to read the instructions on how to utilize this because I'm just messing around with it. I'm not sure I'm utilizing it properly. Expand off, expand on. Well, so the signal's there. You might full screen this here. Why don't I? Okay, I can hear it. Sounds the same. I think you get the best signal to know. Now, again, it's shortwave, it's fading in and out while I'm doing this. So. But it seems like if you just raise this to just where the noise starts coming up, right about there, I think you're getting about the best. Just look over here. That improved. I watch the meter. Just where the meter starts going up seems to be a good spot for this. Well, we can look and see if WWV is around at 20 megahertz. Why don't we take a look at that? See if we can find that one. So I don't see any carrier. Do they still exist at 25? And 15. Of course, I'm running it through here, wasn't I? I was running it through here. Oop. Yeah, I'm going to break this meter at some point. I'm going to bend it. Well, as usual, shortwave not so good. This must be the 770 here. Yep. Okay, let's go back to just straight into the antenna. Into the SDR here. This is antenna straight to the SDR. Give it a minute. Well, it certainly isn't dramatically better. Well, this went much better than I expected. I really thought this was not working at all, but it certainly appears to work, and the problem now is I don't know how to use it. I have to read up on this and find out, exactly how a logarithmic amplifier is utilized, and then can I use it here in my setup, either in the shop here, which I kind of doubt, or just my general shortwave. What I'm thinking is this thing could be sitting out close to an antenna and then receive the signal from the antenna and boost it and then send it further on a cable, to my radio some distance away. So I get an amplifier for remote antennas, something like that. I don't know. But anyway, things went quite well today. So thanks a lot for watching. Tomorrow, this won't be here. I'm not sure if I'll be back on the old radio that's beside me here. This one here, because I need a good idea before I continue with this. And so far, the ideas I've got has to do with these buttons up here. I don't think they're so good yet, so I'm still thinking about it. And, so I may have something else on my bench tomorrow. Who knows? You never know. Who knows what tomorrow will bring. Thanks a lot for watching, and see you later.